The F5 Local Traffic Manager, Traffic Processing Concepts. I mean, how exactly does this magic stuff work anyway? We got plugs, we got network cables, we got things that happen. How does it really work? So I got some objects and stuff going on. We got little pieces and parts and terms that we're going to see and things that we really need to know exactly what they are in the world of F5. Because names are a little bit different when we go from one vendor's load balancer to another. So good to understand the different objects that we're dealing with, and we'll talk about the different methods of packet flow as well. So how do I get from my clients into my servers and of course back and everything working right. So we'll go over some of the concepts of load balancing and really get a good idea for exactly what this little thing right here does anyway. Okay, it is all magic, but it's good because we're going to control that magic. And of course, when we're done with that, once we have things actually working and stuff, then we can talk about what our statistics and logs are going to tell us so that we can maintain our continuity and our connectivity and all the other fun stuff that goes along with it. So, kind of diving into all of these things here. You know, ADC is a very powerful term, the Application Distribution Controller. Those are powerful words, especially in data center environments. So, we've got to really kind of figure out how to enhance that user experience. You know, we hear all these terms, we hear these phrases, these get talked about a lot, not just from marketing, but all sorts of articles and everybody talking about what we need to do. What exactly does it mean? Well, at a fundamental level, we're load balancing. Or we're balancing the demand, so however many users that I have out here versus how many servers in capacity that I have right here. Because that's what it's all about, is capacity planning and, well, call it capacity dealing with. Because we can plan all we want, but that does not make it a reality. So what happens when I have too many users for the number of servers that I have? Or how do I make sure that each one is doing just fine and kind of check things along the way? There's a lot of magic that goes into it, but there's a lot of power as well that all goes into the control at the middle, that application development or distribution controller. So when we start getting down to it, you know, it really seems very complicated, or seems very magical anyway, until we break it down into the pieces. Okay? So when we're talking about our objects and our things that we have going on, well, I mean, look at the basic picture. You have users, you have a controller, and you have servers. How much simpler is it going to be, right? Well, let's look at it at a different high level. Okay? So let me kind of pull out some of the graphics that we have here. Now, as we start kind of looking at this and kind of going through things, the very basic version of stuff is kind of like I said. You got a client, you got your ADC, and you got a server. You have packets coming in, going out, packets coming in here, going out. That seems fairly simple, right? You say, no problem, we can do that. Well, it's a little bit different than that. Okay, so at a slightly more detailed level, we're going to start introducing terms. Okay, so some of the things that we have going on here, like a virtual server. Virtual servers can be my starting point, and that is kind of like being on the outside here. So we'll call it a virtual server here. And that is my public-facing side. Public. So a virtual server itself has to be able to be reached by the clients. You know, there may be other devices over here. We may have routers. We may have, let's see, my bad drawing of a firewall. This is supposed to be a brick wall. And some fire on top of it. Oh, no, I'm sorry. Fire has to be red. So we'll color that in red. There we go. There's my firewall. So anyway, yeah, love my artwork. So we may have other objects out here, but those all have to be configured as such to allow the client to be able to talk to the virtual server here, and of course the traffic going back. So all these things in here, the virtual server is the primary piece. So the kind of central object, if you will, as far as the big IP or the F5 load balancer is concerned in processing traffic. Virtual servers consist of a name, an IP address, and a port. Okay? These three things uniquely identify what a virtual server happens to be. There may be more information than that, but at least you have to have this in order to uniquely identify things. And it'll be good not just from the ADC's point of view, but again from my router, my firewall, or whatever access lists or anything else that I have going on. I need to identify these things as well in order to be able to pass that traffic from the client on the way in. So that's my public side of things, and that's going to be where traffic comes from and how it gets initiated. It's all going to go in this direction. So kind of watch that part right there. Client side, server side. This is the way we kind of refer to things as we'll start talking about all of the balancers. Now, the private side of things, okay, so really kind of going on the inside, if you will, is made up of pools. Okay, so that's my next concept that we kind of get into. And the pools will be paired with the virtual servers. So you may have more than one pool. We get different ways of doing stuff that we'll kind of get into the details of it later. But generalized level for my objects, virtual server flows into a pool. A pool is merely a group of member devices. So pool is my group of member devices. Good definitions to remember. They're going to share in that connection load balancing. So I can have all sorts of different servers. Some may share for an FTP connection, some may share for a web connection, some may share for, I don't know, what else are we going to do? Well, we'll call it application. Whatever it's going to be. Bad times in the morning, I can't think of strange things off the top of my head. Okay. Each one would have a separate virtual server. Each one could have a separate pool. Now, next thing we get down to is kind of pool members. There's actually another concept in here that I'll add in, because we'll kind of talk about it, and that's a node. Okay. So node and pool member are very similar and very important terms to have. So the thing is, they're essentially the same thing, well, kind of, sort of anyway. A node is merely an IP address. Some people think of it as a device, a physical box, whatever we're going to be looking at in there, but technically it's just an IP address. I actually can't configure it because as I create my other things, the node ID gets created for me as being the unique IP address of a box. Now, a pool member is more specific. Okay, so a pool member is an IP/port to a device. So, as an example, when I get down to things, I could have multiple computers over here. So we'll say 3 computers. Okay, so technically I have 3 nodes. Now, this one up top may have www and FTP and app. This one may just be app, this one may just be www. So as I'm sharing things in here, I have a pool member of this node and this node for www. I only have a pool member of this guy up here for FTP, and I have pool members of these two for the application. 3 nodes, but different numbers of pool members that they are. So this one physical box, one node, is actually a member of 3 separate pools because of the applications or the things that are running on that physical box. So that's where we're going to get into some of the differences in there. That's also where we can get into some of our load balancing concepts. Okay, so kind of hold that thought for a minute, but know the distinction between what a node is and what a pool member is, because a pool member is going to be more specific. So we will revisit this when we get into our load balancing concepts in there. But this kind of goes across the slightly more detail, but still high-level idea of my 4 objects that are necessary for traffic processing in my load balancing behavior. So what my ADC is going to do and how it's going to do it all center around these basic 4 concepts and where I'm at. And here's, like I said, the picture from client side to server side of where we're going to be. Now, looking at my last graphic, and I don't want to necessarily pull my details off of here, but remember I just had that device in the middle and client and server showed everything going through. which is kind of a simplified approach. If we were a router or a firewall, that would be exactly what it was, because the same connection goes both ways in there. When I start looking at an ADC, on the other hand, I actually have two separate connections. Okay, so we'll call it number 1 over here and number 2 over here, because my box in the middle is my ADC that will actually terminate the connections. So I have a client-side connection and I have a server-side connection. My TCP sessions for whatever I have going on will actually terminate, and I don't really want to draw a line down the middle because technically it's the entire box, but will terminate on the ADC. So I have two pieces to be thinking of now as opposed to just one single pass-through connection. So that's going to be kind of my difference in here, or my above and beyond, my section about how my traffic objects actually interoperate in there and how the packets actually flow through my ADC. Alright, so as we can look at it, like I said, when a connection comes into a virtual server in there, it's really kind of interesting what the ADC does. Okay? So first of all, it's going to note availability. So of the pool members, basically. Pool, can't spell today. So it's going to look at this in order to help determine what the next target's going to be. Then it's going to look at its load balancing routine that happens to be set up. So load balance across pool members. It's going to do a couple interesting things here then, like I said, about the connections that we have. It'll translate the connection. So going from the virtual server to a pool member, and then it will technically, and it's kind of a new term if you will, but you'll see it in a couple different references as well as possibly the exams, you will untranslate the reply packets. So I'm doing two different steps in there as far as where I have things coming in versus going out over here and then coming back and being sent back over here. So that's going to be my basic packet flow of what we have going in here. Virtual server behavior, I mean, we can alter it on all sorts of different things. So we'll just say altered on, I can do traffic content, and I can do persistence as well. And again, detail-wise, we'll talk about this in a later nugget because we got different methods of persistence. But what persistence means is that the same client or same set of connections goes to the same physical box over on this side. So think about it, and I know everybody's run across this in doing e-commerce or shopping online stuff before. Have you ever gone and looked at all your things and added it to your shopping cart, and then you go to check out and all of a sudden your shopping cart's empty? Well, the basic reason for that is all of a sudden your connection got kicked over to a different physical box, and that physical box had no earthly idea what you'd been shopping for. It's really kind of irritating. So when we do persistence in connections, it makes sure that same client goes to the same box over here because certain information like that needed to be kept in a live type environment. So that's the idea. And like I said, detail-wise, we'll get into that later, but that is an important concept on what can manipulate things based on how our virtual servers are treated. So when we think about, each of these, when we think about each of these connections, there's always pairs, like I said. So there's the client-side pair of connections, so like we labeled that before as number 1, and then there's the server-side connections, which is the number 2 part in here. The F5, or my ADC, is right in the middle of all that and controlling everything. Just to scare you a little bit, we have kind of a graphic that really shows the flow of everything, from packet ingress to really where we get to actually move the packet around. Now, there's a whole lot of things on here that we haven't gone over. So like I said, this is just to, scare you a little bit, but it's kind of half the fun of this, right? But we will see everything that we get through in here on how the ADC goes about processing the traffic, and we'll be able to pull things out of here, which is really kind of the cool part of the exercise, and refer back to this or look at this as you go along and be able to tell what's going on, what kinds of things we look at, and be able to check them off and say, okay, I know about persistence tables, have we done this? Or I know about my health monitors, have I done that? Do I know what the event client accepted happens to be? And these are great ways to go and check things off to make sure that you know them and to make sure that you can follow everything through so we don't see things like load balance failed. Right, so we know what's going on, and of course we get to the end result of moving the package through and having the application work. This is our goal about traffic processing, is to make this graphic make total sense to us. May not today, perfectly fine with that, just wanted to kind of throw it out here right now. By the end of this whole course, all the nuggets that you've been through, we will come back to this, and I guarantee this will make much more sense, and you'll be able to check things off, just like I said, and say, yep, know that, know that, know that, know that. How do we get from point A to point B? So exactly what different ways do we have available to us in order to pull things through, or in order to balance between my multiple servers over here? Well, interestingly enough, there's two main types of load balancing. Now, and we'll expand on that a whole lot more, but we have static and I have dynamic. Alright, so those are my two basic methods in there. Now, even within that, when we get to specific names and things, that's going to be a little bit different. So under our static distribution, we have round robin, and we have ratio based. And pretty much those are exactly what they sound like. So round robin, if I have 3 boxes, simply goes 1, 2, 3, 1, 2, 3, and keeps repeating that over and over again. Has no bearing on how many connections are staying on there, how long they're active, or anything else like that. It just keeps moving back and forth on the initial initiated traffic coming in, so the initial packet flow and where it gets assigned to. Ratio based, on the other hand, will set a weight. Again, not paying any attention to how things are really staying active or what is or isn't going on long term, but just from a static balancing, we may say, 3 connections over here, 2 on this one, and 1 on this one, and it'll do exactly that. So 1, 2, 3, 4, 5, 6, and keep repeating that over and over again. So 3 up here, 2 down here, 1 down here, 3 up here, 2 down here, 1 down here. So it keeps going based on the ratio, and I'll see this is user defined. Okay, so it kind of gives me the control over what that balance happens to be. Maybe one of these boxes is more powerful than the other. Okay? But those are the basic static methods of doing things. Now, under my dynamic load balancing, this will actually refer and relate to not just the availability of these boxes, but also their current performance levels. So this does maintain a little bit more control over talking to the servers, over figuring out what's up with them and what they have going on, and how things are going to be maintained in there. And so I have a number of different kinds of things in here. This is also, by the way, where we may get into node versus pool member. So I can balance based on either one of those and the types that we're about to list. So let me go ahead and list those for you. Alright, so least connections is my first dynamic method, and that really does look at the number of active connections on here, and whoever has the least, it'll keep adding to it. So let's say this guy has 400, this one has 420, and 425, whatever the numbers are. Okay, I will add the next 20 incoming connections onto this server up here. Then I will load balance between the two of these, because they'll both equal, assuming the 420 stays here, but they'll both be at the same number. So I will load balance between the two of those until they get up to here, to 425. When all of them are equal, I'm just doing round robin. So I said load balancing, I meant round robin between them. So least number of connections will keep getting that number until it's equal to the next one. Then they will round robin until we're equal to the next one. Then we'll round robin those till we're equal to the next one if there's more servers, so on and so forth. So that's a concept of least connections in there. Fastest, on the other hand, it's kind of one of those interesting things. Fastest, of course, is a relative term. We'll look this more as outstanding connections. And by connections, I'm actually referring to layer 7 requests. So at the application level, the least number of outstanding requests, so things that the ADC has sent over to the server and waiting for a response back. If there's the least number of outstanding connections or pending connections, that is going to be deemed the fastest box. So I'll balance it that way. Again, kind of a ratio balancing on here, but doing it based on the least number of things that the ADC is actually waiting for. So in theory, less things that the client is waiting for, and can actually process stuff a little bit faster that way. So that's the concept of what the ADC, the F5 ADC, will deem as the fastest connection in there. It has nothing to do with link speed or anything else. It is purely on a processing basis, or more so on a I'm not waiting for you basis. My least number of sessions is used a whole lot with persistence. C. And that really is kind of like it says, whoever has the least number of sessions right now, and it'll round robin between them until it starts them up. So it's just like least connections, period, except that it's specific to my persistence records. So a little bit different in that. My weighted least connections, on the other hand, is again going to be kind of like our ratio based over here, because what I will do is actually set connection limits. So I may have a 500 connection limit on here. I may have 600 on here, and 600 on here. And we'll do the same kind of thing. So we'll do least sessions, but it will be weighted based on what my maximum number happens to be right here, and what my user-defined scaling happens to be. Okay, so that's going to be a little bit different. These, again, are very specific on whether I do node versus member-based or pool member-based. So when I start looking at that, especially when I'm talking about my sessions in general, remember we had this before where I had, and I'll just kind of consider two different things, so my web traffic or FTP traffic. If I have my virtual server number 1, pick a different color here. Okay, so VS1 is web, VS2 is FTP. So if I'm looking at my servers, if I have 100 web connections and 200 FTP connections, and then I have 200 web connections and 0 FTP connections as far as my server number 1 and server number 2. When I start looking at my balancing on here and kind of think about this from what's going to be going on, especially web versus FTP in terms of traffic processing or bandwidth processing, and what the impact is going to be. So if I look at least sessions on a member basis, that will only treat my web by itself, which means this guy is completely underutilized. If I look at it versus a node basis, I have 300 connections on this node versus 200 total for this node over here. So this one is the least utilized of them, and especially considering FTP would be more traffic intensive than what the web stuff is. So you can see why it's a very important thing to consider when we're looking at all of our balancing in there, whether I'm talking about node or whether I'm talking about pool member. Okay? So there's going to be where my play comes in. And again, going back to my different objects and my things to look at, Obviously, in this graphic, I'm not listing node at all, but it is going to be important when I'm choosing my method of load balancing and how I'm considering this, based on all the different applications that I have. If all my applications are equal in terms of performance and statistics and stuff like that, I could probably care less which one I use. But when we start getting different balancing, like one's very traffic intensive, one's very processing intensive per packet sort of thing, then it may make a difference for where I'm going to be and what I'm going to be doing for it. Observed and predictive are kind of interesting. They're ratio-based connections based on average. So we'll say an observed average on both of these, and then weighted. Now, observed gives a 3:2 ratio. So if I have below average connections, I'll get 3 connections in 3 of the next connections in my round robin balancing. If I'm above average, then I'll get 2 of them. So a slight skew towards bringing the others up. If I do predictive, it's going to be a little bit more drastic because I'll do a 4:1. So my underutilized, my under average things, below average devices will get 4 connections to every 1 connection the above average happens to get. So it is constantly observing things. Trying to remember how often we look at stuff. Okay, so every 1 second, I had to go look that up just to verify, but every 1 second is where I'm doing my balancing on here, my averaging, and figuring out what that's going to be. So I may have a server popping back and forth between the two of them, very often. There's a lot of work then that my ADC is doing to kind of watch that and, again, observe or predict what's going to be going on. But it is a weighted averaging for round robin. My dynamic ratio, on the other hand, is a lot more involved. It is specifically SNMP based. And there's going to be things that the ADC will pull from the server to see its load. This is used a lot in streaming environments, looking at connections, long-term connections, and things like that going on for them. The real network system, as an example, does that a whole lot. There's a lot of different things that will go on for it for media-based applications. But this is going to be much more observation, if you will, or looking from the ADC, checking on the health of the servers to see their connections, to see the CPU, to see how everything is performing, how the disks are performing, and all that stuff. Again, in order to make sure that the user experience, so my UE over here, is as good as it can be in that type of environment. But that pretty much covers my different load balancing concepts of what my F5 ADC is capable of. So of course, when we set our virtual servers up, we'll pick what we're going to be using in here, but these are going to be the options that I have available to me and what they actually mean in terms of that process. Okay. Couple real quick things that I wanted to kind of add in here as far as my load balancing and stuff goes. First one is priority groups. By default, we have a group 0. I can't spell. So group 0 by default, but I can add other numbers to that. And really what that's going to have is a different pool, if you will, or a different set of pool members that get activated based on threshold. So we'll say based on threshold, to be active. Think of it like a fallback or extra load, or however you want to think about this, but it's only going to do certain things. And again, we can look at this on looking at my servers, that I have certain ones that are primarily web servers, certain ones that are primarily FTP servers, certain ones that are primarily application A or application B. But in the event of a high client usage, I can say once all my main pool is full or utilized, or God forbid they all failed, but once they're all being tied up, then I can bring in the next highest priority group. So the next group of servers involved. It may be FTP, but I can also have them do web as backup. Or they may be application A, but I can also have them do as web as backup once the web servers and the FTP servers are full. So I can get into all sorts of control of multiple groups and failing groups over in order to, again, help out my user experience over here based on my use of priority groups. I also have one other thing called a fallback host, and this is done in HTTP profiles, but in case everything fails, all of the members of a particular pool fail, this is a redirect HTTP basically to an apology page, an unavailable page, something nice that you configure other than, hey, it just failed. So again, going back to my user experience, even in failure, I want to be able to deliver nice messages or deliver something that's meaningful rather than it simply can't get to it. This kind of helps out your help desk sort of thing. So that's where a fallback host is actually done. And that really kind of covers my concepts of the balancing and that user experience that the F5 is going to bring us. Now next I want to get to our last thing, which is statistics and logs. And these are really both going to be GUI based in terms of what I'm looking at and where I'm at for things. So statistics are certainly going to be important to us, and those are actually one of the top things in the navigation bar, that left side navigation bar of my GUI. I can get stuff like my packet count, and this goes in connection count too, and this goes for all sorts of different things. So I can look per virtual server, I can look per pool, I can look per NAT, I can look per SNAT. You got lots of different details that I can get to in there. I also have the capability of doing a dashboard, which is a live view of those statistics and throughput and CPU usage and things along those lines. I can look at requests, errors, responses, various things within a profile that I've got on there, as well as being able to match certain things on persistence records and stuff like that. I also have use counts for iRules when we get into those. Basically, just look at the statistics section of the GUI. Same type of thing for logs, by the way, although this will actually be under System and Logs. So everything we have in there, we have various log files. We have a messages log file, which covers pretty much everything. I have a packet filter log, which based on what I've configured will contain that type of information. I have local traffic, which is things that are destined to and from the actual ADC itself. I have audit logs, which are going to be based on what I've configured as well, so different configuration things that I do. In my configuration system, so configuration and options, I can change the different logging levels or what I'm going to be logging on here. Everything from the logs, by the way, will be in the /var/log directory. So this is messages, var log messages, this is var log PKT filter, this is var log LTM. These will be named based on what you configure. So that's my different concepts that I have for my statistics and logs as far as getting into where my ADC is going to be used. Alright. So kind of going over things from our zero to movement, I guess is kind of a good way to do it, zero to speeding. We've talked about our load balancer in general and the different concepts in here. So my concepts included the types of load balancing, my terms of load balancing, so what different pieces are going to be involved. We'll call them terms or pieces. As well as the actual flow of traffic. So how does the ADC actually deal with things in there? And then really kind of ended up with, after our flow, so after we get things configured, which we'll talk about next, and see our traffic flow, what kinds of stats and logs are we going to be able to get out of it? So really everything from the beginning thought process to the pieces that we have to put together to then the flow of traffic once it's working to what do we do to observe afterwards. Conceptually, this will get us from a design to a use, we'll call it design up here, to usability down here, point of view for my F5 ADCs. I hope this has been informative for you, and I'd like to thank you for viewing.